All right. So, in the last class, we looked at what do you call it? We looked at indices, right? And for your indices, we solve different exponential equations. Our focus was on solving exponential equations, and today we'll be looking at logarithm. And I told us to go look out for your sword. I told you to go check out for sword so that it will be easier for us to cover our syllable. And this morning we'll be looking at logarithms. I'll be solving as many questions as possible from your past questions regarding your logarithm. So now, what are the key things we need to know? There are key laws around logarithm, and there are key things that we need to know. So, for example, let's say we have something like this. Let's say we have log two. Sorry, let's go this way. Let's say we have log two base 8. Now, what they are asking you is which number will I raise to, right, 2, so that I will get 8. Do you get the point now? What's the power that I can take 2 to so that I can get 8? So in simple terms, 2 raised power what will give me 8? That's what they're asking you. So we have log 2 to power 8. It's simply asking me which number will I raise? 2 raised power what will give me 8? I think that's the best way to say it. 2 raised power what is going to give me what? 8. That's what they're asking. And we know that 2 raised power 3 is equal to 8. So therefore, log 2 base 8 will be equal to 3 because 2 raised power 3 is equal to 8. We can have series of that. So that's what your logarithm revolves around. What will I raise to a particular power so I can get the very digits? So okay, let's say we have this again. Let's say we have log 3, log 3, log 3. We're in base 3 now. Log 9 base 3, I mean to say log 9 base 3, right? Because the one down is the base, the one up is the logarithm. So now what that simply means, which number am I going to raise? 3 raised power what will give me 9? I think that's the best thing to be saying. 3 raised power what is going to give us 9? We know that 3 raised power 2 is equal to 9. So therefore, log 3, 9 will give us what? 2. That's your logarithm. So another thing can also be this way. We can as well have something like let's say log base 2, log 4 base 2. So which number will I raise? What number I'm going to get if I raise 2? So I can get 4, right? 2 raised power what will give us 4. That's simply what the thing is trying to tell us. So now log 2, log 4 base 2 will be equal to 2 because 2 raised power 2 is equal 4. Now on a sorry. Therefore, on a general note, the logarithm of a number is simply trying to ask you for that particular base, which number will I raise that base so I can get the target value. That is simply what your logarithm is all about. They will have different laws of logarithm. Sorry, I was making mistake in terms of what I was saying. It's not usually easy. All right. So based on that, let's look at the concept of logarithm and then see what everything entails. So let's say we have our logarithm now. So we have logarithms. Now let's say I have log A base B. So the one down is the base, then the value A is your log. So log A base B, let's say that it is equal to X. What that implies is that B power X will give us A. So that's the easiest definition we can actually give regarding basis. That's the easiest. So we have this equal this. What does that imply? So if we want to speak a little grammar on that, we can say that a logarithm answers the question it answers the question to what power must b, that is this b, to what power would b be raised to give a, that is simply what the logarithm is trying to ask you, right? So, and I've given examples on how that's the possibility of all of those things and how it can be, right? So, to give more examples, I can have to what power if I have log 27 base 3. It is simply asking me to what power am I going to raise 3? What power will 3 be raised so that I'm going to get 27? We know that 3 raised power 3 is equal to what? 27. So it simply means that log 327 is equal to 3. So these are key things that we need to know and we need to remember. Now, also, let's say we have, if I don't give the base, it means that it's in base 10. For example, if I just write something like log 100 without maybe putting a base on it, it simply means that it is log 10. Right? So that's one thing I want you to know. If you write a particular logarithm without putting the base, remember that the logarithm will always be this way. You have log, this is A, this is B. So this is the base, right? So if I write a logarithm without the base, it means that we are talking about base 10, right? So now let's say log 100 simply means which power, remember that it's going to have 10 automatically. So which which number will I raise 10 to so that I can get 100? So you can see that 10 raised power 2 will give me 100. So therefore, log 10 power 100 is equal to what? Is equal to 2. Likewise, log 1000 base 10 is going to equal to 3. So you just count the number of zeros. The another key thing that we also need to observe is when it comes to decimals. There's going to be a trend on that one when it comes to decimals. So for example, let's say I have log 0.1. Remember that if I didn't include the base here, it means 10 will be equal to negative 1. Log 0.01 will be equal to negative 2. Log 0.001 will be equal to negative 3. So you know the trick now. Let's say I have log 0.00001. I just count the number, right? So have how many zeros do I have? So 1, 2, 3, 4, 5. That will be equal to what? Negative what? 5. Right? That's for decimals, right? So these are the key points that you need to always remember around your logarithm, right? Which other thing? Also, if I have something like let's say log 4 to 16, it is simply asking me which number will I raise 4 to so I can get 16, and that is 2. Now also observe this. Let's now assume I now swap the base. Let's have 16 4. When you have a bigger base, like if the logarithm I take is bigger than the base, you should expect a whole number. But when the the thing is swapped, we'll be expecting a fraction because of the what? The base is bigger than the number you're looking for inside the logarithm, right? So the base bigger than the number inside our logarithm. So this is going to be equal to what? 1 over 2. So these are the key concepts around your logarithm. That is what everything revolves around before we start talking about the laws of logarithm, right? So these are key points. So when I have a bigger number as my base, right, I should expect a fraction. Are you seeing that now? But when I have a bigger number than the base, I should expect a whole number, right? And when I have a fraction as my base, I should expect a negative number. So when we start solving questions on that, you're going to understand it better. All right, so let's look at the laws of logarithm. I'll just pitch my net on just about 5 of them. So let's look at the laws of logarithm. Yeah, if you're with me, give me a thumbs up. If you're with me, can I get a thumbs up? All right, so let's look at the basic laws of logarithm, right? So the first law is the multiplication rule or the multiplication law. So that law you can use this law to either condense or expand a logarithm, right? So multiplication law is very handy when I either want to expand or when I want to what condense. You're going to see what I mean by expand and condense a logarithm. You're going to see that come to play in terms of expansion and condensing a logarithm. So now multiplication law says that if I have log AB, it is equal to what? You can expand now log A plus log B. Remember that this is only possible if they have the same base, right? If they have the same base, then this is possible. Are we together now? So we're assuming that the base here, let's say they have base 10. So this one will be log 10. So which means that if I want to solve this, they certainly should have the same base, right? So we're assuming that the base we'll have here is base 10, base 10, base 10. Because any base that is written without indicating what it is, that means it's base 10. So the base must be the same, just like in your indices, for you to add them together. So you have logarithm 3 here. It means you can actually add them together, right? So it depends on what? On the basis. They must have the same base for that very rule to hold. Now the next law is your, your division law. So for your division law simply says that when I have something like log A over B. Remember, they should have the same base. That is simply equal to what? Log A minus by what? Log B. You subtract. They have their 10, 10. Now, the next thing I want you to pay attention to is what we regard as the power rule or the power law. And then we'll solve examples. We'll get our hands dirty based on that. Right? Is that you have something like log A, remember I said that if I'm not indicating the base, it means it's in base 10. It can be any base, provided they're in the same base, then you can add them together, right? So if I add this to the power n, it simply means I can bring this n down, log A, right? Then the next one is the change of base. If I want to change the base, right? So change of base formula, these are the 4 key laws we're going to be applying for our logarithm today. So we have the change of base formula. So for the change of base formula, we have that log A, the base was AB, so you want to swap it. So it's going to change to, is similar to you bringing it up. You can say log, this formula is very key, log B all over what? All over log A. So let's quickly look at sample problems. You understand? Let's look at examples now. All right. You'll see how we can apply these rules, right? So for example, let's look at how you can expand. Let's say we have log open bracket 6x squared. Let's say we have this. How do we go about this? Let's expand this. Remember, because they are together, we're saying that this should be base 10, right? The base here is base 10 because it's not indicated. So now let's expand. Remember your multiplication law. If they are multiplying, it means that we can separate them this way. We can have log 10 6 plus log 10 x squared. Now, anytime you have a log carrying a power, you can bring it down. So we can simply go that this is log 10 6, then plus x log 10. So you've seen that you've actually expanded. You've actually expanded. So you can use those rules to either expand a particular logarithm or you can use it to condense that particular logarithm. So it's in two ways, depending on how you want to simplify them. So let me show you an example now where I'm going to expand. Does it make sense? So let's quickly expand now. Let's condense, I mean to say. So let's say we have a particular logarithm. They give us something like sorry, let's say they give us 2 log x minus log y. So at this point, I'm going to condense it. I know that this is, I can bring this guy up here, right? Applying the power law. So this means I have log x to the power of 2 minus, sorry, this is log x squared, because we're assuming that this is base 10, right? Minus, anytime you don't have the base given, just know it's base 10, y. Now, when we are subtracting, we remember that it is coming from where? Division. So this same thing as saying that you have log 10, open bracket, x squared divided by y. So you've seen that we've actually what? We've condensed it. So that's rule number 1 and rule number 2, which is your addition law and your multiplication law and your division law, can be used in condensing or expanding your logarithm. That is exactly how it works, right? So let's solve more problems on this so you understand better how we can actually condense or compress our formulas, as the case might be, using examples. Now, let's say we're asked to simplify this. Let's have our example 2 now, right? So example 2. Let's say we are asked to simplify log 16 minus, sorry, it shouldn't be log 16 this way, minus log 2. Now, solution. You can see that it is expanded. They gave us the expanded form. So for us to simplify this, we have to take it to the condensed form, right? And what can we do? Remember that this same thing as saying log 10, 16, because they have the same base, minus log 10, 2. But there are cases where the bases are not going to be the same. You now have the responsibility of changing the base so that they have the same base, right? All right. So that said, let's proceed. Now, the next thing I'm going to do is to check properly to see how we can bring them together, because they have the same base, right? Log 10, log 10. It becomes challenging when the bases are not the same. All right. So that said, I have log 10, 16 minus log 2, 10. Now, what will I do? I'm going to bring in my division law, right? So recall your division law that will help us to make that guy condensed. So recall the division law. So for the division law, we are going to have log 10, 16 all over 2. Now we've condensed it. So I'm going to have log 10, 16 divided by 2 will give us 8. Are you there now? So we're going to have our final value is going to be equal to what? This is equal to what? Log 8. Right? So we've actually simplified that very value, right? And there's nothing we can break down further right here. Now, another example we could solve here. So anytime it is expanded, your goal is to make it what? Condensed. And if they are giving it at something that is condensed, you're going to expand it, making use of the laws that are being given to you. So let's say simplify log 4 plus log 25. Now, how do I simplify this? Now, let's have our solution. It is expanded, we have to condense it. Now, condensing it simply implies that we're going to do, I'm going to bring them together right away. So I'm going to have log 10, open bracket, 4 times by 25. And we're going to have log 10, 100. So the question, which number will I raise 10 to the power of so that I can get 100? 10 raised power of what will give me 100? We know that 10 raised power 2 will do that. So now we can say that this is equal to x. It means that 10 raised power x is equal 100. Now, based on the laws of indices that I explained before, you can solve this way. So 10 raised power x is equal to what? 10 squared. So 10 cancel 10. you have that x is equal to 2. Or you can still make use of what I said earlier. Which number will I raise 10 to the power of? Or 10 raised power 10 raised power what will give us 100, right? So that's exactly what I did. Or you can still apply the concept of what you learned during your indices. So that x is equal to what? Is equal to 2. Therefore, you've simplified that very logarithm, and that logarithm that was asking us the log of log 4 plus log 25 is simply equal to 2 based on our simplification. Now, the next example we might be looking at, let's say we have something like this, and let's see what we can do through that. Let's say we have example 3. This time around, it is condensed. So when it is condensed, you expand. When it is expanded, you condense. So you are going to make use of those laws to either expand or condense. So we have log 2x is equal to 3. You can see that this side is condensed. I'm going to expand it. So solution. So let's expand it using the laws of logarithm. So this will give me log 2 plus log x is equal to 3. Are we together now? We've expanded. Give me a thumbs up if you are still with me. Can we get a thumbs up if you are still with me, guys? All right. So now we have that log 2 plus log x. So when I simplify further, I said this is equal to 3. Now, the next thing we're going to do now is to simplify further. So always observe if it is in the condensed form, we expand, right? So I've expanded it to log 2 plus log x, right? And with this, let's assume that they gave us, let's say, that log 2 is equal to, sometimes JAM will give you the value 0.310. Yeah, JAM can give you this. So when you're giving this, that very value, it means you can go ahead and plug it in. So what that entails, anywhere I see log 2 now, I'm going to plug in 3.01, right? Unlike in SNCE exams that they want you to expect you to make use of the logarithm table, right? But for this one, you're not expected, they will give you the value. So there's no need of making use of logarithm table, right? So this will now be this plus log x equal to 3. Now I'm going to simplify further. I will have that log x, let's collect like terms. We're going to have at this point that log x is equal to 3 minus 0.3010. So that log x is equal to 2.6990. So there's something else I want to do now. We can take the exponential form, right? We can have that log x is equal to, you can sometimes you can leave your answer, just leave it this way, right? Let me not make it so complex. It's just our first examples, so that when we start going to past questions, we can now I treat them accordingly. So we have that log x is equal to 2.690, right? So any question on this? I hope that we are making sense. Another thing that we can do, instead of doing this pattern that I did here, another thing that we can do, obviously, is to introduce log here. Look at something else I can do, right? So imagine that this thing is not given to us. So let me actually erase this. Let's say that the log 2 was not given to us. So look at what else I can do to get my answer, right? Let's say they just said log 2s is equal to 3 without giving me that particular value. So look at what else I can do, right? I can simply say that, okay, let's say simplify this. So solution, instead of breaking it, we can introduce something. We'll have log 10 here in bracket 2x is equal to 3 is something as saying log 10. Yes, if I have 1000 here, Yes, because the number I'm going to raise power, 10 raised power 3 will give me 1000. So log 10, 1000 will give me 3. So I have not changed anything. So still the same thing that I'm doing. So therefore, with that now, I can cancel. So assuming they didn't give me the value of 3, right? So look at what I said. Now they gave me the other one I did. I assumed that they gave us something like log 2, and I'm going to come to that kind of example where they will give you that log 2 is equal to a particular value, log 2 is a particular value. But for this one, they didn't give us anything on that. So what am I going to do? Now, remember what I said. If there's no log, if there's no base, it means that it's in base 10. Now I have log 10 to 2x is equal to, when there is 3, I know that I can actually introduce logging to the other side, just like you normally do in your indices. When you have something like 16 is equal to 2, let's say 2 raised power x, you now have to find a way to break 16 down to have the same base. You will now see that this is 2 raised power 4 equal to 2 raised power x. That's the same thing I want to do. I want to find a way to break this 3 down so it can have the same log 10 as the base. And the only thing I can remember to do is that log 10 1000 will still give me 3. You've not changed anything. Because logarithm simply says, what am I going to raise to the power of 10 so I can get 1000? Sorry, what will I raise 10 to the power of? Or 10 raised power what will give me 1000? You observe that 10 raised power 3 is going to give us 1000. So we've not actually made any change to the question, right? Our goal remains that we have the same thing on the left hand side and the right hand side, just like we normally do for our indices. All right. So that said, you could observe something that will now have the same base on the left hand side and on the right hand side. I hope that makes more sense now. I hope that makes more sense now, right? A thumbs up, guys. Okay, beautiful. So it's the same thing we'll do. We're just playing around as always. So now this cancel here, this cancel here. So we're going to be left with this. We're going to be left with 2x equal to 1000. So I'm going to divide both sides by 2, divide this side by 2 as well. And when I do, I'm going to have that this will cancel through. So we'll cancel out. This will cancel out. So therefore, we'll have that x will be equal to 500. So your knowledge of, that's why you cannot separate indices and logarithm. They are siblings, right? Because the rules are almost similar. And there's a relationship between the both of them at every point in time that we could actually navigate through and apply through as well. Now, let's solve more questions on this. Let's say that we are expected to do something like this. Let me move to your past questions now so that we can solve more questions on that. All right, so look at this very question number 16 for a particular year. So I'm going to use that as my example number 4, right? So example 4. So now they said I should simplify simplify log x plus 3 equal to log 7. So let's see what we can do based on what we've learned so far. So solution. So what am I going to do at this point? Now, nothing has changed. The process is still the same, right? Observe something that anytime you have this kind of thing, they have log, it simply means it's base 10. So you can observe they have the same base. This is log 10 here. This is x plus 3. This is equal to log 10. I'm trying to show you something. And that's why we always endeavor to ensure that they have the same base on the right hand side so that we can simplify, especially when you have an unknown. Now, our rule at this point is that here can cancel out. 10 can cancel 10. We're now left out with something. We now have that x plus 3 is equal to 7. So that x is equal to 7 minus 3. and the value of x is equal 4, right? So that's the role that that guy really plays for us to simplify whatever thing we're looking for. So therefore, we have that x is equal 4. Let me solve another unique example, right, before we get our hands so soaked into more complex things, because these are just the basis of your logarithm that you need to understand, especially applying the laws of logarithm and how it's simplified. All right, so look at this example now. Let's say example number 5. So for example 5, we are asked to simplify log 5 plus log 4 minus log 2. So now you could see that it has to do, they have the all of them have the same base. It becomes a problem when they don't have the same base. In other words, this simply means we're doing log 10, because if the base is not given, that simply means that we're working with base 10 there. Then log 10 4 minus. So it is expanded. So we need to find a way to condense it. At every point in time, always find a way to condense. So now what this thing simply means is that we can bring in the multiplication law at this point, right? So this simply implies that I have log 10, open bracket, 5 multiplied by 4, then minus log 10 2. And when I simplify that multiplication, I should end up having that log 10, open bracket, 20, minus log 2, right? Now, the next thing we're going to do now is applying our subtraction. That's our division law. So I have that log 10, open bracket, 20 all over 2. So that will give us log 10, right? So which 10 raised power what will give us 10, right? So you're going to see that log 10 is equal to 1. So log 10 is equal to 1. Right? So therefore, this simply means that you know why I got 1, because what number am I going to raise power 10? 10 raised power what to give us 10? That will give us 1. 10 raised power 1 is 10. So therefore, we have that logarithm, which is log 5 plus log 4 minus log 2 is actually equal to what? Equal to 1. Because log of the same base will give you that same base, right? So I think it's also a rule that you should take note of when you are simplifying logarithms. It's a very powerful rule. Log of the same base will give you 1, right? So take note of that. This is the power law. But then I think I omitted something very interesting, something very powerful. So these ones are also included. But then we omitted that log AA is going to give me 1. Log BB is equal to 1. So log of the same base is going to give us that will give us 1. All right. So right there, let's see if we can actually solve more and get our hands much more deity. So let's see this example 5 example. Let's look at example number 6 and see what we can do from example 6. Now, let's say we're asked to simplify all of this thing revolves around the addition and subtraction law. Sorry, the multiplication and division law, I mean to say. So simplify log, open bracket, 49p, right, minus the log of the decimal number 0.01, right? So this simply means that they have the same base at the moment. So solution, we have log 10, as the case might be, open bracket 49 to p, right? So minus log 10, 0.001. Sorry, that's 0.01. So the first step, or the first thing we're going to do, is to expand the left-hand side. So this is something I'm saying log 10. If I expand, or there's any to expand, we can actually go straight to dividing. There's no need of expanding again, because for here it is being multiplied. This is 49p, right? This is log 10 0.01. I've explained this log 10 0.01. It's going to be how many numbers now? It's going to be negative 2, if you can remember what I told you before. you count the number of zeros based on what I explained when I started in the first time I started, right? So 1, 2. So it has 2 zeros. This one is 1 0, 2 zeros, or 1, 2, 3. So 1, 2, 3, 4, 5 zeros. Just that way. That determines the number you are going to have. And that's the same thing I'm going to apply right here. When I'm dealing with decimals, just count those decimal points and you are good. All right. So that's the same thing I'm going to apply right here. So there's no need of expanding again because the left-hand side is already condensed, right? So once it's condensed, please don't expand. That means the work has been reduced for you. So now the next thing I'm going to do, let's divide. This means open brackets 49p, right, divided by 0.01, right? Um, alternatively, alternatively, what I can do is to, if I simplify that left hand side, it will not really give us what we are looking for. It will not really give us what we are looking for. Let me observe a better approach that I can take lead of based on this. What better approach can we use? All right, so let's go this way. Okay, so this is this. But we know that 0.01 is the same thing as saying 1 over 100. Is that also? So that means that I have log 10 open bracket 49p divided by let me change the division symbol so that it doesn't get you confused. So divided by 1 over 100 because I've turned that 0.01. Now that means that to further simplify this, we'll have log 10 open bracket. This is 49p all over 1 times 1 over 100. So further simplification of this simply means that we're going to have log 10, then 49 times this will give us 49,900p, right? So which means that this is equal to what? Log 4900p. There's nothing else we can do right here, and that's the simplification for that very problem. So let's solve those ones I was talking about, the kind of values they can give you, and then you plug in accordingly. So sometimes you might see questions that looks like this, and you are required to solve them. Now, what do you do in that kind of situation? So let's have example number 7. Still on your logarithm. So let's say let's use this particular question that sometimes might actually surface where the values are given. If you have your past questions, you can as well check more questions so that we can solve it right away now. If you have your past question, quickly check them. That would help you, right, to ensure that everything that we needed to solve, that all of them are solved. All right. All right. Okay, imagine this. We have that if log 4 is equal to 0.6021, and I'm asked to find log 0.04. So watch that tweet there. Look at how they twisted the whole thing. So they've given us log 4 to be 0.6021, and I'm now asked to find the log of 0.04. So what can we do right here? Now, one key thing that we can do here is that remember that we have something key here. Now, solution. That log 0.04 is the same thing as saying if I bring in subtraction now, I think that would work as well. It's the same thing as saying log 4 all over 100. If you agree, give me a thumbs up. Log 4 over 100, right? So that said, good. This is the same thing as saying that I have log 4 minus log, if I do this, I hope you not be confused, 10 raised power minus 2. Remember that the base here is 10. This is also base 10 here. What do I mean? 1 over 100 is same thing as what? 10 raised power minus 2. Law of negative index. Do you understand it? Law of negative index. Okay. Now we have something like this. We have, when you have something like a minus 1, it's something as saying 1 over a. If you have a minus 2, same thing as saying 1 over a squared. So when I have 10 raised power minus 2, it simply means 1 over 10 squared. And 1 over 10 squared will give us 1 over 100. Does it make sense now? Does it make sense now?
4 over 100. Yeah.
I didn't hear you.
But I thought we have 4 over 100, not 1 over 100.
Yeah, 4 over 100, yes. 4 over 100, I've splitted now. I've applied, that means you're not following. I've splitted now. I've applied my division law. When you are dividing, you are subtracting. Remember that this same thing as saying log 10 here. So now I've splitted and I have log 10 4 minus 1 log 10 1 over 100. Do you understand it now? Sorry. Now, for your division law now, when you have something like this, if you have something like log A over B, simply means log, are you there? Simply means log what? Log A minus B. Is that also? Good. Log A over B means log A minus B. Now, good. Now, you are working with log 10, log 10, open bracket, 4 all over 100. Now, so this should be equal to what? I can split it into log what? Log 10, are you there? Minus what? Sorry. It means I have log 410 minus log. Okay, now I get your point. Yeah. Log 110. Is it clear now? Good. Now I get your question now. Now, what else can we see right here? So it is the same thing now because 0.04 is 4 over 100. You are dividing, right? So, and 4 over 100 is more like you have log A over B, right? Log A over B. And with that, you can now simplify further, right? Okay. So now, based on that subtraction that we have right here, the next thing that I can do now, remember that this same thing as saying um, log 4, because if I'm not writing the base, it means that I'm base 10 minus log 100. Now they're giving us the value of log 4, but it doesn't stop there. We know that log 4 minus this same thing as saying log 100 is same thing as saying log 10 to the power of 2. Remember, here is log 10 as well. 10 squared is 100. Do you agree now? So that said, it means that we're going to have log 410. They've given us the value of log 410 already. They said it's 0. Sorry, is 0.06021. So this is 0.6021 minus, you can bring this guy down here, 2 log 1010. If you understand that, please give me a thumbs up. Good. Now, and I said that log 1010 will give us 1. Log to the same base will give us 1. So this is 0.6021 minus 2 times what? 1. So I have 0.6021 minus 2. So therefore, this is going to give us what? So it's 0.6021 minus by 2. That will give us, this will give us equal to what? Negative 1.3979, right? So therefore, what does that tell us? That simply tells us that log log of that very number we are asked to calculate, which is log of 0.04, will be equal to what? Minus 1.3979. Does it make sense now? So it's about breaking down the whole thing and looking for a particular process based on what is given to us. So nothing changes, not something so complex, but it's about us breaking it down and following whatever steps that is given to us. All right, so observe this one as well. Let's say we have something like this, and let's see what can be done through that. All right, so look at this one. Let's do something a bit harder. This is example 8 now. Let's say we are asked to solve log x minus log x minus 1 is equal 1. Do you see what is happening there now? So what can we do? Solution. The first thing that we can do, anytime it has been condensed for you, don't condense it again. The work has been made easier already for you. So now the remaining expanded form will be condensed. I'm going to apply the division law. So the same thing as saying log x all over x. So this will be log what? Log x all over x minus 1 is equal to 1. But I told you something. You need this left-hand side to have logarithm as well. I will ask myself, since this guy is in log 10, base 10, I mean to say, I will find something on the right-hand side. And that is what? Log 10 here, I have x minus 1 will be equal to what? What am I going to do here? Log 10 will give me 1. I've also replaced this 1 because log 10 will still give me 1. And what did I do? I did that in a way that this place can now cancel out. Here can go out. Here can roll off. So in the end, we now have just these guys remaining. We now have just x all over x minus 1 is equal to 10. This is over 1. Then we'll cross multiply. So this will give us 10, x minus 1 is equal x. So when we open our brackets, we're expected to have 10x minus 10 is equal to x. So this is 10x, right? Minus x is equal to 10. So this is 9x is equal to 10. So we're going to divide both sides by 9, which is the coefficient of x. And when we do, you're going to realize that the value of our x is now equal to 10 over 9. So logarithm can be interesting if you understand the rules and how to play the game. And sometimes it can be also confusing if you don't really understand how the whole thing is being done. All right. Let me solve another example that has to do with plugging in the values. And let's see how that goes. All right. So imagine they give us, let's say we'll have something like this. That's the example 8 now. Please start checking your past questions, or you can check online as well. This is example 9. So for example 9, if log 2 is equal to 0.3010, oftentimes we see this kind of questions. So log 3 is equal to 0.4771. Then I said we should find log 12. So our goal is to find a way to break this 12 down so that it can contain all of this variable that was given to us. So solution, what can we think about? We know that log 12 is something as saying log 4 times 3. Is that also? Now, since you've multiplied, you can now expand it. So it turns to what? Log 4 plus log 3. Remember, when you are not writing the base, it means that it's in base 10. Now, log 4 plus log 3. But there's something else that was given to us. The only information we have is log 3. We don't have any information on log 2. Now, for the right-hand side, we don't have any information on log 4. but we have a key information on log 3. And our log 3 simply says 0.4771. So we have 0.4771. All right. So what can be done so we can have 2? Remember that this is 4. It also means log 2 to power 2, right? Plus 0.4771. Then based on the power law, we can bring down these 2 here. So we now have 2 log 2 plus 0.4771. Now, that said, on that, what that simply implies is that I can now go ahead and look for the value of log 2, which is 0.301. So we now have 2 multiplied by 0.301 plus 0.4771. Now, what is the value of 2 times 0.301? That will give us 0.6020 plus 0.4771. When we add them together, we're going to have 1.0791. So what does that imply? It simply means that log 12 is equal to 1.0791. So that question will always come without using table or calculator, simplify, right? That's how they usually ask the question. Without using table or calculator, simplify. So your own duty is to start breaking them down to ensure you now have what the variables that we are actually giving to you. And I hope that all of these things are making real sense to you. Any questions so far? All right, so we are good to go, right? I've solved on to 9 examples. Let's check more questions and see what we can do about that. All right. So now look at this one. This is JAM 2005, right? So they gave us something like this. This is example number 10 at this point. Please confirm you can still hear me, please. All right. So we had something like this. We have if log two x plus 4 equal 5, find x. This is what we are asked to do, right? So how do we simplify this? These are the kind of questions that we'll be seeing as long as your questions are consigned. We'll keep seeing questions as this. So what do we do? All right, so this is actually 2 here, is in base 2 actually. So sorry about my error. So we had something like this. This is log base 2 of x plus 4 equal 5. So it's supposed to find x. Now, solution. Remember what I told you about logarithm. Logarithm is simply asking you which number will I raise to 2 raised power what to give us x plus 4. So this thing simply means that 2 raised power 5 gives us x plus 4. That's what it means. So remember that when I have something like log, let's say b power a equal x, it simply means that b to the power of x is equal to a. So that same thing is applicable here. So for that very number they gave us, which is log 2 open bracket x plus 4 equal 5, it simply means that 2 raised power 5 is equal to x plus 4. Equal to x plus 4. Now 2 raised power 5 should give us what? Power 4 is 8. Sorry, 2 raised power 3, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. That should give us 32. So we'll have that 32 is equal to x plus 4. Right there. So that simply means that we have that x is equal to 32 minus 4. Right. so that x is equal 28. Does that make sense? A thumbs up if you understand what we just did now. A thumbs up if you understand what we just did. Beautiful. So it's not really a big deal, right? It is about you understanding the process and applying the rules of logarithm accordingly. Is actually nothing to panic about once you get the concept. All right. So let's look for more jump past questions on logarithm, which I think I leave that to you. We'll have the past questions on the group. You can as well check out for other platforms that can be of help. All right. Um, so let's look at logarithm. Let me solve more questions on that. And let's see. Um, this one is a bit dicey, but I'm going to solve it. This is JAM 1999. Sorry, 2003, I meant to say. So let me quickly solve that. So they said we should evaluate. Let me call it example number 11. They said we should evaluate log base root 2, log 4 base 2 plus log 1 over 2 base 16 minus log 432. Did you see what happened right there? So I'll solve this one, and the subsequent ones, I'm going to leave it to you to get your hands a bit dirty. So what can we see here? You could see that, okay, let me rewrite them before I start talking. It's not a big deal. Sorry, I forgot to write evaluate properly. So now solution here. Now let's interpret this thing very well. This means we have log 4. Root 2 simply means what? What does root 2 means? It means you have something like 2 to the power of 1 over 2. Is that also? A thumbs up if you get what I'm saying. If you get what I'm saying, give me a thumbs up. No, now you guys cannot be giving me a thumbs down because you have that square root of 4. You did indices, so it's wrong for you to give me a thumbs down, right? So you have square root of 4 is same thing as 4 to the power of 1 over 2. When we did the fractional index, we said that when I have something like b to the power of c over p, it simply means what? The cube root, that p will be here to the power of b c. So when I have something like 16, 1 over 2, it simply means square root of 16. If I have 16 power of what? 1 over 3, it simply means the cube root of 16. Can you remember your laws of logarithm now? Good. Makes sense. So we're going to rewrite the basis now. We're going to rewrite the basis as much as we can, but I'm going to do something very mind-blowing now, and I want you to get set for all that. All right. But I don't think this example is going to choke you, right? I think it's not the right time to start doing this kind of complex work now. So what will happen? Let me keep solving the ones that this one requires I flip the base. And when I do this, it might not be funny. When I flip this, it might not be funny. So let me just maintain and possibly give you that as a work I want you to do, right? Or should I go ahead and solve? Are you sure you're going to follow through? Okay. So let's get our hands dirty. All right. So I've explained something here about how I want to break that down into what you know, right? So we need to convert everything. That's the key thing I'm going to do so that they will have the same base. That's what I want to do, right? So let's find a way so that they will have the same base because it stands now. each and every one of them have different bases, right? Remember when I started, I told you something that the problem might come to a point where the bases are not the same. So your work now is to convert everything so that they have the same base. So the first base here you could see is 4. The base of this one is root 2. Now we need to work on that very base. And I said that root 2 is the same thing as saying what? 2 to the power of what? 1 over 2. Let's break it down. Now, 4 is the same thing as what? 2 raised power 2. Are we together now? Good. Good. Now, um, let's simplify this further. Or let me even leave this one as 4 for you. Let me not break it down. So do you know what that first term is trying to say? The first term is now saying that we have something like this. The first term is trying to say that I have something like log of 4, right? And I have 2 to the power of 1 over 2. Good, is equal to x, because I'm trying to check which number will I raise to what do you call it? 2 1 over 2 to the power of x is going to give us 4. Is that what it means? Is that also right? If what number will I raise to the power of 2 over 2 to have 4? Good. I'm glad you are following me. So now, what does this imply? This simply means that we now have something like this. We now have 2 1 over 2 to the power of x is equal to 4. This is something I'm saying 2 x over 2 is equal to 4. But remember something very interesting when we did indices, that 2 power of x over 2, I can break this to 2 raised power 2. Is that not so? Now, I can cancel out this side of the equation. So let this cancel out this. Then I'm going to end up with x over 2 equal 2. So that x is equal 4. That means we've simplified the first part of the equation, right? The first part of the equation has been simplified. And what that entails is that that very first part, this side of the equation evaluates the whole of here has been simplified. Is that also? So, which means that we've actually broken that guy down into something interesting, right? So that's how to approach these problems in the very simplest way, right? So that means that the first part of our equation, which says that um, log of root 2 power 4 has been broken down to be equal to 4. Now, the next part of our equation is this side that says that log of 1 over 216. That's the next thing we want to simplify, right? So we have log 1 over 2 power 16. We have to equate it to the power of x. It simply means that 1 over 2 to the power of x is going to give us 16, right? So it entails, you give me a thumbs up if you understand the acrobatics I'm doing at the moment. Okay, beautiful, beautiful. Now, if I do this, hope you will not be confused. If I say this is 2 raised power minus 1 to the power of x is equal to 2 raised power 4. A thumbs up if you're not confused. I apply the law of negative index, that 1 over a is equal to a minus 1. So that 1 over 2 is equal to 2 minus 1. A thumbs up if you get this point. If you don't understand it, give me a thumbs down. No response? No, now now it means you still don't know your law of negative index, and it's not a good one. That's here now you don't know your law of negative index. Now the law of negative index says if you have something like 2 raised power minus 4, it simply means 1 over 2 raised power 4. 2 raised power minus 2 is something as saying 1 over 2 raised power 2. So therefore, if I have something like 1 over 2 is something as saying 2 raised power minus 1. Law of negative index. Does it make sense now? Good. Now, and that's exactly what I did, right? And what that entails is that at the moment, I now have something like 2 to the power of negative x is equal to 2 raised power 4, right? That's why we learned indices before now, because indices will help us understand things on logarithm. So 2, we cancel 2. So it means that negative x is equal to 4. But what I need is x and not negative x. You multiply both sides by x, by negative 1, so that x is equal to negative 4. So what does that tell you? It tells us that the logarithm of that guy, 1 over 2 power 16, is equal negative 4. So we'll have the first part of the equation simplified as fast as we can. So we've simplified this guy. Now, the second part has been reduced to this. Now we have the next. If I'm solving this thing for myself, I should be done by now, right? But then it's entirely fine. We need to get the concept. Now, the next thing I want us to look at is log 432. Are you there? Log 432. Let's quickly break log 432 down in the simplest form. All right. So log 4 power 32, it simply means is equal x, right? And that's why we learned the meaning of logarithm from the onset, because I know that a time like this will come. Now I'm going to have 4 power x is equal to 32. But we need to break this thing down further. This will give me 2 raised power 2x is equal to 2 raised power 5, right? Now that said, it simply means that what do you call it? That 2 is going to wipe out 2. So when it does, I'm going to have 2x equal 5. Divide both side by 2, divide both side by 2, and therefore we now have that x equal 5 over 2, right? So therefore we'll have that log 432 is equal to 5 over 2. Now we can now go ahead and add everything together, right? We'll add everything together. So remember that this is the third one, right? This is the third one. Then we'll have the first one. So this is the second one. That's the value obtained from that very guy. And then finally, this is the value obtained from this guy. So what am I going to do? I'm going to put them all together based on the equation they gave us. Remember, it says everything is being added and the last one is subtracted, right? So I have 4. It's going to be 4 plus negative 4 minus 5 over 2. So that means I have 4 plus negative 4 plus 5 over 2. That is 4 minus 4 plus 5 over 2. And that will be this will be 4 minus 4. Sorry, here is negative rather. The final one says negative 5 over 2. So I have negative 5 over 2. So that will give us 0 minus 5 over 2, which is equal to what? Minus 5 over 2. Right there. All right. So which means that, are we together? Which means that that very long question they gave us, therefore, we'll have that the logarithm of root 2 4 plus log of 1 over 2 16 minus the log of 432. Log of 432 is equal to negative 5 over 2, right? Or you can say negative 2.5. Do you understand it? Does it make sense? Confirm that it makes sense. Beautiful. Now I have another one, 2008. That one says that should be your example. This is example 11. I'm using your past questions as examples. So this is example 12. So this one simply says that if this is 2008, if log x, this is 1 over 2, right? Then 64 is equal to 3. we should find the value of x. You could see something a bit dicey there, but the process has not changed, right? So they said that we have log what? The base is x 1 over 2, then we'll have 64 right there. You could see that it looks as though they are multiplying each other right there. Well, let me look at that question, whether they are multiplying. Let me look at that past question again. Are they multiplying each other? Okay, no, they are not. This is the way it is. We'll have log x is here, 1 over 2 is here, then 64 is here. Yeah, that's the way it was written. Are you still with me? So I will solve this one. So I'll give you context to this. Then the next problems you are going to try, or maybe let me solve as many as possible. So when you get home, you solve the ones you can solve, basically. I think that will help you. So let me cover as many examples as possible from your past paper. Okay, so solution. Now, what can you see right here? Now, this is the base. So let me simplify further. This is log. Remember your base, a over b, right? Or b over a. I can't remember how let me go back to that example I gave you. Yeah, it's equal to x, b over a, right? Good. B over a, that's what I gave you. So from the onset when we started, b over a is equal to x. So from our problem now, we have log, the base is 1 over 2, then 64. And b. This simply implies that your b is equal to 64. A equal to x 1 over 2 in bracket your base. Are we together? Do you understand what I'm doing at all? If you understand, please, can you give us a thumbs up? So this is the base right here. Now, but since we have something here, and from our question already, we have that x, right? Or let me call here p, since I have x already. That p here, p is equal to 3. They gave us the value of p already from our question to be equal to 3. Now, remember what I taught you earlier, right? That log BA equal P is simply saying that that A will be equal to what? B to the power of P. Or the other way around, that B power P is equal to A. That's the definition of logarithm. So that's the same concept I'm going to apply right here. All right. So that said, we could do the same thing right here, which we've actually seen here, right? Remember the simplifications that we did and how we are going about it. So we've agreed that P is already 3, right? So let's go ahead and apply what we can apply at this point. So that implies that the value of my B, like I said, is 64, right? So I have that B power P. So that means that I have X. I think I'm missing up things. I'm trying to use an example that makes more sense. BP is equal to A. Okay, sorry, based on my example, I'm making a mistake. So I should maintain the same thing here. So this is AB. So it means that B, sorry, I want to maintain the same example so that as you're reading from this beginning, you can always make reference. So this is AP is equal to B, right? So that means that I'm going to do X 1 over 2, that's my base, all to the power 3 is equal to 64. Yeah, do you get what I did there? Give me a thumbs up if you just understood what I did there, applying the laws of our definition of logarithm, right? So that said, we could open up our brackets from your indices, expansion of brackets. So it means x product power law 3 over 2 is equal to 64, right? Now, remember there's something that we could do. X is 3 over 2, we'll have 64. So what can we do right here? Are we together? If you are with me, give me a thumbs up, please. All right. Now, I want to do what I call acrobatics now. When I have something like x to the power 2 is equal to 64, to get the value of x, I do x equal to square root of 64. Why am I doing square roots? Let me draw a line here before I do this. Now, recall. This is a very crucial thing I want to do now. So get ready. So recall that if I have x raised power 2 equals 64, I will take the square root of both sides. What I normally do was to say x2 open bracket 1 over 2 is equal to 64 to the power of what? 1 over 2. Because I have to, right? So now, in this our case now, what I will do is I'm going to take the reciprocal now. So it's going to be x 3 over 2 to the power of what? 2 over 3 is equal to 64 to the power of what? 2 over 3. When that happens, why did I do that? So that 2 can cancel 2, 3 can cancel 3. I'm now left with what? I'm left with x is equal to 64 to the power of what? 2 over 3. Remember your fractional power law. Fractional power law says that if I have something like a b over c, it is equal to the cube root, the c root to the power of what? Of b. Remember your fractional power law. That's why you cannot separate indices from logarithm. If you are good with indices, automatically you should be good with logarithms. So this means that c is equal to the cube root of 64. When I get that cube root, I will now square it. Now, which number will I raise to the power 3 to get 64? Number will raise to the power 3 to get 64. Is there a number like that? That's cube root of 64. Any number like that? That will give me 4. Yeah. 4 raised to the power 3 will give me 64. So that means that x is equal to 4 raised to the power 2. So that x is equal to 16. Right? So what that implies or what that entails is that very thing that we're asked to solve right there that looked complex. I didn't hear you.
You wrote 2 instead of 3.
No, now. I wrote what?
4 is to the power 2 instead of 4 is to the power 3.
No, it cannot be 4 raised to the power 3 now because you have 3 under. So the one under determines the cube root you are going to take. If I have 2 under, it's going to be square root. But I have 3 under. So cube root. When you get the answer, you now square because that one is up. Do you get? All right. So x is equal to 16. So therefore, it means that very question we are trying to solve, where they said that log x 1 over 2 to 64 will be equal to what? Equal to 3, so that x equals 16. So for you to actually do well in this logarithm, you must understand your indices so well. And that's why I took time to teach us indices, and I solved as many problems as possible for your indices. Now, the next one I want to solve at this point. Let's see how we can go about that. All right, I've solved this question. I've solved this one. Now, this one says something like this. This is my example 13 now. So for example 13, we have that if log 10(2) is equal to 0.301 and log 10(7) is equal to 0.8451. Evaluate. evaluate log 10 to 80. All right, so if you think they gave us 7 and they gave us 2, right? So how do we simplify this? We look for two numbers that can give us 280. So we just have to take it off from there. So two numbers that can give us 280. So I can just do 280 divided by 7. Let me see. That will give me 40, right? But the one they gave me here, they gave me 2 and they gave me 7, right? These are the three variables they gave us, 2 and 7. So we'll have the workload of trying to see how best to navigate this. How about 280 divided by 14? That will give us 20. So I'm going to look for two numbers that can split 180 for us. That can split 280 for us. So what are those two numbers that can split 280? We are given 2 here and we're given 7. So we have to be very critical at this point to see how best we can navigate. Two numbers that can give us this. All right, can I think? Let's think. Because we are giving log 7 and we're giving log 2. So we have to just think critically, think about two numbers like as fast as we can. Even if it's not two numbers, but we must find a way to break it down. Just like I solved that very particular question that time. We must find a way to break it down, the both of them. Right. So let's solve. I'm thinking about two numbers that can be of help at this point. Thinking about two numbers. So let's go with 14 times by, or 20 times 7 will give me 40. 280 divided by 7 is what? That will give me 40. So I have 7 times 40. But how do we break down 40 to the barest minimum, right? So these are the work. This is the work you need to do. It's more like when you land land prime factorization, you are trying to break down a composite number. That's the same thing that happens here. You have to think, including your sword. Sometimes they give you a sword of something like 72. You start looking for two numbers that when you multiply, one of them will give you a perfect square, so you can break it down. And that's what we're trying to do. So now let's consider the numbers that we can use, right? Our goal is to break down 280. So let's think about 280. 280 is something as saying 28 times 10. Then we'll see what can work for us. Now we can break 28 further. I'm trying to apply prime factorization now into something like 4 times 7. Are we there now? Now, it's not really prime factorization. I'm just trying to use something that can make the work easier for us. Then I can break 2 down. I can break 4 down into 2 times 2. So what it means that at the end of everything, we can have that 280 is the same thing as saying 2 times 2 times 7 times 10. That will still give us what we need. So let's now apply the law of log reading. So I have that log 10 280 is equal to log 10 open bracket 2. Are you there? 2, which is something as 2 squared, right? Times 7 times 10. Or you can say 2 times 4. You can put it as 4 here. Then later we can break it down. Now it's expanded. It's condensed. Let's expand. So this means we have log 10. This is 4 plus log 10 7 plus log 10 10. Now we don't have log 4. What they gave us was log 10 7, which is 0.847, and log 10 2. But remember that this one can be broken down into log 10 2 squared plus we have log 10 7 plus log 10 10. Now I told you log 10 10 or log of the same base will give you 1. So I can move this guy to the other side. I will have 2 log 2 base 10 plus log 7 was given to us. Log 10 7 is equal to 0.8457, right? This is okay, let me just continue. Log 10 7 plus log 10 10. Now, but from the question, but but we have that log 10(2) from the question is equal to 0.301. Then log 10(7) is equal to 0.8451. And then finally, I've told you that log 1010, log of the same base, log 1010 is equal to 1. So let's go ahead and simplify. So I'm going to have 2 open brackets 0.30 plus 0.8451 plus by 1. So when I use my calculator to simplify this, I'm going to have 0.6020 plus, this will give me 0.8451 plus 1. So this is equal to, if I add everything together, we should have 2.4471. All right. So that implies that that very question that was given to us, that log 10, are you there? Log 10 280 is equal to 2.4471. So I'm going to box everything. All right. Any question, brotherly? Does it make sense at all? Yeah, a thumbs up if it makes sense. Yeah, I hope you're learning something new. Like, hope you're gaining more confidence. Hope you're gaining more confidence as we solve. Yeah, a thumbs up if you are. All right, so look at this one. Beautiful. This is example number 13. So if I get to example 15, I think that'll be enough. And I believe I've given you few things that you need. So example 14 now. All right, example 14. Meanwhile, have you gone through the sword I gave you and that logarithm? Are you done? Because that was our target for last week. Because I was down, that's why we're still doing this. Are you there? We are able to cover that. That was the target for last week. So if you are still doing sword, remember this logarithm should be what we should have done last week. But because of my health, we couldn't do that. So I believe that the target I gave you for the other sword and the other ones, you guys have completed it by now. Right? So example 14 says that we should simplify. That's past question. This is 2021. So simplify 2 log 2 over 5 minus log 72 over 125 plus log 9. So 2 log 2 over 5 minus log 72 over 125 plus log 9, right? So how do we go about this? Okay, so remember as always, and look at the options they gave us. They said option A, they gave us 1 minus 4 log 3. Option B, they gave us minus 1 plus 2 log 3. Option C, they gave us minus 1 plus 5 log 2. Option D, they gave us 1 minus 2 log 2. So these are the options that were given to us, right? And we are asked to get our hands dirty doing that. All right, you ready? A thumbs up if you are ready. Okay. So as always, let's break it down one after the other, right? I like approaching that one after the other. So I have that 2 log 2 over 5 is the same thing as saying log you bring up that 5, that 2 rather, all squared. So this will now be equal to what? Log 4 over 25. Let's keep it right there, right? Are we together now? So the next thing I want to do, since I have that very one, remember that it has expressed itself, and I have log 4 over 25. Now, the closest one there is minus. So let's have minus 72. Sorry, not 72. Minus log 72 over 125 minus log 72 all over 125. So apply the division law. So that will be log open bracket 4 over 25 divided by 72 over 125. So when you are dividing, you should cross multiply. Is that also? You should invert the sign. So this will give us log open bracket 4 over 25 times 125 all over 72. So it's about time we reduce to the lowest term, right? So 25 into itself will give us 1, right? 25 here will give us 1. 25 into 125, 5 times 5, 25, 5 carry 2. So that will give us 5, right? 25 times 5 should give us 125, right? So I have 5 remaining here. Then I have 72. And I know that 74 can go into 72. 72 by 4 to give us 18. So 4 here is 1. Here is 18, right? So we're now left with the logarithm of 5 over 18. All right. Hope you understood that very division I did right here. So I have logarithm, the log of 5 over 18. Then remember that we left something by the side, which is it minus or plus right here? Okay, it was a plus 9, right? Not just 9, that should be log 9. This is log 9. So we now apply our multiplication law by combining them together. So we should have the log 5 over 18 multiplied by 9. So when that happens, something can still divide. 1 go here, 9 go here, give us 2. 9 here will give us 1. So 9 times 2 is 18. Is that also? So that will give us log open bracket 5 over 2. Now let's look at our options. We'll see that the options is not in division form. We'll have to still go back again. We'll have to break this thing down further. So this is also equal to applying your expansion now. So expand. I'm going to expand it. It's condensed at the moment. So let's expand. If I expand it, I'm going to have log 5 plus log 2. Are you there? Log 5. Sorry, not plus, minus, because we're dividing, minus log 2. Does it make sense? A thumbs up if it makes sense. Yeah. All right. Next thing that we can do. So they gave us this question. They said plus log 9. All right. So our answer, all the options we have here is minus 1 plus log 2. So how do we break this thing down? Log 5 minus log 2. Log 5, log 2 is something as log 5 to base 10. Yes. Yes. So let's simplify further. Let's simplify further. Are we together now? Do you know what I want to do? Our answer is not yet in the options. We'll have to still break it down further to have exactly what they have. Now, I've subtracted based on division. Now, the next thing we need to do is to find a way around this log 5 is something as log 10 5 equal to x, right? Log 10 5 is equal to x. So 10 raised power x is equal to 5. Um, what can we do? 10 raised power x. So 5 is the same thing as um, um, log 10 10 equal 5. Okay, makes sense. I'm still trying to see how we can break this down further. This is 2021 past question actually, so I have to break that down. Now, what if I do this? Remember that this same thing as saying log 10 5 minus log 10 2. So what can we do? Now, can we break this thing down further? I'm going to have something like okay, instead of having this log 10 here, can I do this? Let's have log this same thing as saying 5 over 5 over 5 over 10 to give me 1 over 2. Is that also? Okay. So let me simplify further. So let's have this as log 10 over 2 minus log 2. That's because of the step they gave us there. I'm trying to simplify further so I can have an option right there. But we're on point. Now, log 10 over 2 minus log 2. Are you there now? Because 10 divided by 2 will still give me 5. So there's nothing bad I've done so far. We are still on point, right? 10 over 2 is still going to give us what? 5 minus minus log 2. Does that make sense? So I think when I do that, I can break this guy down further. It's going to be what? Log 10 minus log 2 minus log 2. A thumbs up if you understand what I just did. A thumbs up. No, yeah, I'm not talking about a person that just joined. A thumbs up if you understand what I did. Justice. Justice. Are you here? So now, look at what I did. We had log 5 minus log 2, right? Now, but this is the final answer we got. But when we check our options, you can see that there's nothing like that in the option, which means that there's something else that we need to do further, right? And we're going to be applying the laws of indices to simplify that further. And based on that, we have that log 5 minus log 2. 5 is the same thing as 10 divided by 2. So 10 divided by 2 will still give you 5. You've not changed anything. Then minus log 2. Now, expanding this log 10 log 2. 10 over 2, they have division. So I'm going to expand it further. So let me do something here. Let me start from beginning here. But we have that log 5 is also equal to log 10 over 2. And from division law, we have that log. Remember that this is the equation I'm currently. Let's call this our equation 1, which is coming from here. Now, from division law, we have that log 10 over 2, which is log log 10 over 2 is equal to division law. We have log 10 minus log 2. Are you seeing it now? So let's call this equation 2. So therefore, when we bring everything together now, bringing everything together, we now have that log 10 minus log 2 minus log 2. Yeah, I hope that makes more sense now. So now I have that minus log 2 will give me 2 log minus 2 log 2. So this will be log 10 minus 2 log 2, right? But remember that this same thing as saying log 10, 10, because when the base is not given, that means it's in base 10 minus 2 log 10, 2. Now, log 10, 10 is 1. Log of the same base will give you 1. So that will give us 1 minus what? So I have log 5, yes, which is log minus 10, 10 minus 2. Okay. Then I will have minus 2 log 2, because you can remove that base 10 there. So that gives us the final answer, which is 1 minus 2 log 2. And checking the option that it tallies with, you will see that this should be our answer, 1 minus 2 log 2. So answer is D. So sometimes they just want you to play around, right? They just want you to play around to see whether you understand what you are doing. This is option D. But remember, initially that was not given to me. I had to play around to actually get to the final question, and that's exactly what I did. All right. So any question on that? Any question on that? Yeah, beautiful. So that's just how I simplified that, and I broke down everything to get that very value right there. Okay. I don't think there's any other thing that I need to solve here that I've not actually solved for you people, right? I've broken down everything in a way that anybody can really understand. So go to your past questions, solve as many questions as possible. You can try this one. You can try this one out and see what you are going to get. So let's have example 15, which is the last example for the day. All right, so find the value of y if log y plus 8 plus log y minus 8 is equal to 2 log 3 plus 2 log 5. Right. So the options, they gave us option A to be y equal to plus or minus 5, B equal to y plus or minus 10, C equal y plus or minus 17, and D equal y plus or minus 13. So you can solve that very question. Let it be what you are supposed to do, right? So try and tackle that very question as your assignment. Snap and send to the group. Just get your hands dirty as much as you can. Okay, there's another one here. Solve that very one. Let's have the next one to be your example 16. This one says evaluate. This is JAMB 2022. Evaluate log 2, 8 root 2. So option A, you have 3.0. Option B, you have 4.5. Option C, you have 3.5. And option D, you have 2.5. So go ahead, solve that question. Get your hands dirty as much as you can. Okay, I want to include another one. That's example 17. So 3 questions for you to try out on your own. I've solved close to 14 to 15 examples, and I think that's a lot already. This one says find the value. This is 2000 and okay, this one is 1979. We should find the value. Find the value of log 10 1 over 40, given that log 10 4 is equal to 0.6021. All right, and they gave us the options. The options that were given to us, the first option A, they said is 1.379, 3979. Option B is 2.3979. Option C is minus 1.6021. Option D is 2.6021. So do well to submit your assignments before today runs out. I wish you all the very best, and I hope that you get to minimize your time and manage your time wisely, because there's little that we can do compared to the kind of workload you guys have. So you can take a screenshot of this. However, I'm still sending the notes to the class, to the group, so that you guys can make use of that. So all the best, everyone. I wish us the very best. Right. So take note of that and run with it. Yeah, Mr. Hillary, thank you so much. You can now end the recording. God bless you, sir.